Hello again from Skip, Victor Echo 6 Bravo Golf Tango. This is one of the projects I mentioned earlier. A friend had given me this old piece of gear. It's a nice old spectrum analyzer, but he had picked it up by the handle and it dropped to the floor. The thing weighs about 30 pounds, so it did some serious damage. The biggest problem was that the plug-in or slide-in module wouldn't slide in anymore. And once I removed it, I could see why. The main frame, or the front frame, we'll call it, of the whole unit was badly cracked and broke right there, as you can see on the bottom left-hand corner. Plus, it was very twisted, so you can imagine the slides and the way the module plugs in was really out of skew. So that trick was to get this thing apart and try and fix this, glue it up, or do something with it. This thing took such a hard thump that I wondered even if the CRT was even any good. So I plugged it in, and I got a nice bright dot in the center of it. So I thought, okay, we're good to go, but I should have known better. So I needed to get this front aluminum frame off this thing, and the only way I could see it was I could see in the side here that there's these bolts up in here, and they're underneath the cover. So I needed to, get this off of here, and that was the issue. How to get that off there, I just couldn't quite figure it out, and I finally figured out how I could do it, and it was a bit of a struggle. So after I took all the nuts off, different part, and pulled the power switch out, I thought this plastic cover was going to come off, but it is being held on tight by these nuts. I got these nuts off, but this one here was not coming off, and I figured, there's more to it than this. So I took out the manual and I had a look, and it didn't show me much, but it finally clued me in. I had to take this thing like this. I pulled all those wires off on the other side. There's all the wires interconnecting. Pull the power switch out. Let's see if we're still in view here. Oh yeah. And the circuit board in here, I don't think we're still looking in view. Yeah, this one in here is where the controls are tied over there on this bracket. So once I got all the wires pulled off, I took the power switch out, and then I unplugged this, and I've had this loose already. It's still tight. There we go. So the whole darn thing comes out as an assembly, like that. And you can see the dust. Anyways, these were the wires were connected onto, and up there were the high voltage leads. So with that out of there now, I can get at these screws. Help me pull the front end apart. I'll see if I can show you if I can get this thing held up. And kind of hard doing this all at the same thing here. There we go. I'm gonna get down here yet. Tripod. Anyways, there's these screws here and here, and that will lift this front panel off. There's a rivet up here. I'm not sure what that's all going to do, but we're getting to it, and then I can get that front panel off and get at this crack here and try and get it straightened out, and I'll reassemble it a little bit and see if the module slides back in. So it's coming. We'll see what happens. So I finally got clued in how to take these boards out of here. I don't know what I was thinking. I figured the panel had to come off the front, but it's all one part. I think just gotta pry the boards up a little bit. Simply slide out the front. I took all the knobs off. I didn't have to do all that. Oh, we still got some wires hanging up here, though, I see. And then a couple of wires here. Gotta be disconnected, so we'll draw a little chart here. This one we have 5 and 6, so something like that, like a 5, 6, this is green wire and a white wire. Yeah, it just pulls off. There's an HP2 on there it's got to work with, but I think that's all the wires there are. Yeah, it looks like it. So comes. There we go. I might have to pull a CRT out of this thing to get this front panel off. I don't know. I've tried taking these two nuts off the top and they are tight. Really tight, so we'll see. Anyways. Well, I'm getting these screws out here, but boy, the heads of the bolts or screws are sunk in there so deep that I can barely get the wrench on the head. And I still think I'm going to have other issues here, but I want to see what's going to be loose here once I get all these out of here. Along the top, just keep it. There's a rivet right there. I just don't know how that comes off. That's what it is. Oh boy, I mean, this whole bar might have to come off. Jeez. Oh, this is getting ugly. There was two little bolts holding that top bar on again, but in the front, but I darned if I could see how to get at them, so I went to the back, and there's two bolts here, which meant I had to get the back panel off to drop it down to get at the stupid things. So I got the CRT loose. It's dropped down below the fuse hole so I can hold it up and get these screws out of here. I could hang on to the CRT. I don't know what's going to happen when I get this all off. Damn thing's going to fall apart on me or what? Well, I got the front end loose. Now, if I can put this back together, let the CRT support itself right side up, I can maybe tip it up again. Boy, it's a real pain in the butt getting this CRT out of this thing. I didn't want to do that. Quite a contraption. Alright, some tools out of the way here. I think she'll support itself now. Got more shields broke loose. Let's see. Oh boy, this is going to be a challenge. Are we in view? Well, not particularly, but we'll go back a bit. So I got this plate loose now. I'm hoping it won't go apart. Look at that. Oh boy, the CRT is just sitting there though. I don't know how this is connected onto here. Crazy. Hoping this is going to be all right. Yeah. I just don't want to bump it. Trouble is I got to put it all together to see if it's going to fit once I get it fixed. Yeah, this is a part now, so I'm taking these long screws out of here. And there now. Ah, the front glass came off. Good. Plus this piece. I'll set this over here. That's just plastic. I don't know if you're seeing this or not, but oh yeah. I got some shielding here. There we go, that comes out. Fatty faceplate. Well, okay, that's alright. We can screws here now. I can take them out. I don't think I need to. I'm just going to work on this thing. See, it's got this bad crack. See if I can bend these. Oh yeah, there's our brake. There's a rubber gasket in there. Huh. Okay, well, tough part done. So now, see if we can fix it. I did take that top bar off. I mean, it was just going to be in the way. Took it out in the shop and tried bending and manipulating that bent frame, but of course it broke right off then, so I had a couple of pieces. So with good old JB Weld, I slowly built it up. Took about 3 days because this stuff was not the fast drying type, and eventually got to a point where I could take all the clamps off and do something with it. Once the JB Weld set, I just took a file and a little die grinder and smoothed out the surfaces. Let's see if it, I got the frame on. It's bolted in different places, so down at the bottom here also. So we'll see how it's going to fit. Oh, I just noticed something. This whole frame is twisted. I don't know if you can see that. Yep. I'll be darned. I never noticed that before, and that's why this thing isn't fitting. You see the, see if I can bring it in closer. Man, this thing took a wallop. I don't know if it's going to work or not, but here, I'm trying to get the camera lined up. You see the here to here? She's in. Yeah, that's going to be an issue. Well, let's see how far off. Man alive, I didn't notice that before. Oh, brother, that's going to be interesting. In the slots. In the slots. Now it's gone up further than it did before. But I can see the issue already. I'll see if I can show you this. Okay, I slid it in there, and it does go in farther, but there's no sense. It'll push in farther, but you can see this whole frame has got a bend. So I think I got the pot metal done. I think the framework's done now. Just got to figure out how to get that fixed. Oh, brother. Yeah, I was gonna take the whole darn frame off, and I thought I was out of whack. I thought I was gonna have to take this frame and somewhat, but I'm glad I noticed that that plug-in module is crooked. So, boy, this thing took a whomp. I'll tell you. I didn't take any pictures of this, but I undid a pile of screws and bolts on the whole frame and kind of twisted it and got it close, but it just wasn't close enough. So it, I hate to say it, but it wouldn't quite fit. It's so close it hurts. And I don't think I'm ever going to get it straight, so I'm going to do the unthinkable. Take a little off the aluminum. And mark some spots where it needs a bit of trimming. Ain't nothing to lose. It's so close that it hurts. Taking it apart again and trying to bend it, just we'll never do it. So I'm gonna just shave it down a little bit. It don't need much. It's just these corners mostly. If it doesn't work well, I got nothing to lose. Here. Well, we'll try that, see what happens. Brutal. So we're going to try and slap this thing together to see if it works. We got to put the boards in and get all those wires hooked up. In the meantime, I am going to do some echo testing. So I got the amp going here. And just percolating away all the computers and stuff like that. We're just letting tubes warm up, and we'll shoot some echoes maybe here a little later also in this video. So anyways, back to the scope for now. Get over here again. Let's try that. So we got a bit of a conjumbling here. We got boards and wires that have to go together. And what we're looking to see here at the top. Oh, you'll get the idea. Oh, I got pins and wires, and they're all on this side here. There. Oh, we got a wire here. We got a wire broke off a connector, so I got to solder that back on. We'll get it in here for the first anyway. So I'm gonna break that off. So this has got to go in here like this. And these wires, I've got to connect, and I've got to. Okay, let me look at this first. I have this red and orange. So I don't think it makes any difference. Several control might be backwards. Let's see if we can. How did I do this last time? Not putting this in it backwards. No, it's the right way up. Jeez. I don't know how I did this. Oh boy. Not made easy to work on, that's for sure. But anyways, I gotta get these wires poked in there and then all at once, so we'll one step at a time. Well, it looks like it's working. So I forgot to do some recording here, but anyways, nothing exciting. So I got the board on this side, the board on the back side done. I think you can see that. Yeah, back up in here. All the wires hooked up, so I think we're ready to test it. I'm gonna turn it on without the module in it first, and then put the module in and try that after. So we shall see. 1 minute here shortly. We'll give it a whirl. Well, it's in there, but it just don't go all the way in. But I can't see why underneath it. I mean, it's straight up tight against the chassis and all that. So it's just a matter of being bent. Still sticking out there a little bit right here. Look at that. Well, I'm not gonna worry about it. I want to see if this thing's gonna work. So let's fire it up and see what happens. Let's see if we get some smoke or what. Plug it in. And turn the volume down on the moon thing over here. And well, here goes nothing. Get ready on a cord. Oh hey, we got some frequency display going on down there. That's a good sign. Got no beam. Did we find a beam yet? No. Let's CRT warm up. Tuning. Hey, look at that. It tunes. No beam though. Beam finder. Oh, there it is. But okay, how do we get? Oh boy. Position. Our beam finder's right there. And the focus is working, but we got no horizontal deflection. And that's not good. Yeah. Rats. Base clicker, trigger, time. At least the frequency's working here. That's a good sign. Start in center. Start with center over here. I'm not sure how that even works, so we'll see. But blast! How come we got no external coupling? Maybe take that off. Horizontal position, nothing. No, we got a deflection problem. I know before I had a dot here. I had a resistor pop on me here when I first tried it earlier, and it now we got no sweep. So that's unfortunate. Oh, look at that! Something went by. Nothing excited about. Oh, maybe. Oh, look at this. I think that switch is so dirty it hurts, but yeah, we've got no horizontal display, no horizontal sweep. I'm not sure what I'm doing here. Yeah, there's no sweep. How come? Position calibration. No, we got no horizontal sweep. Well, that's unfortunate. Intensity works. Intensity seems to be doing something. Focus does something. Scale. Oh, that's weird. Oh well, off to a good start anyways. Oh. No, they're all sweet. Well, rats. Oh well. It's going to be easy. Oh, well, here we go. It was at this moment that I suspected something bad. Now, as you can see, no horizontal deflection whatsoever. Lots of vertical, but no horizontal. The other thing I noticed too was intensity. I wasn't going to worry about that, but it really has no effect on it. The focus does. But the intensity control is not. I should almost blank it right out. So that should have been another indication right there. But anyways, that's what's happening. So with no horizontal deflection, I hooked up my scope lead on one of the deflection leads going to the deflection grid or plates, whatever you want to call it anyways, and to my surprise I'm seeing what I kind of expected to see. It was a kind of a sawtooth thing, and I went up to the other side and had a look at it, and you know, still there. Same thing. So I said, well, thinking, why isn't this thing giving me a horizontal deflection? So I hooked up second lead here, dual trace, turned on A2. I'm on already. Let's see, let's get A2 up. Let's move A1 up to the top here, and here's A2 to the bottom. So I'm going to hook up lead on each of these. And what I should be seeing is, let's get the voltage going here. A2, two sideways, or two, you know, more or less sawtooths, but they're in phase. They shouldn't be in phase, and that's what threw me. They're identical on both. One should be 180 degrees out of phase, so one's going positive, one's going negative. And this is where I got a little puzzled, so I went back over to the scope, to the machine here, and we'll just pause this and get to the next test. First, some basic CRT theory. I know there's a lot of younger people out there, not of my generation, that won't have a clue what I'm talking about. So this is a pretty basic diagram, or I'll call it a block diagram of a basic cathode ray tube. It's just a vacuum tube again, like any basic electronic tube. It has a heater, filament, and a cathode. Some control grids, which we won't get into, but you can see we have a vertical deflection grid and a horizontal deflection grid. And then there's a plus 20,000 volt connection at the front, and it's an accelerator grid. So when the cathode is heated by the filament, it emits electrons and forms a beam that goes down the center of the tube towards the front where the plus 20 kV is, being it's a negative charge. The 20 kV is an accelerator which helps pull the beam towards the green phosphor of the glass, and when an electronic beam hits that green phosphor, that's what glows, and that's what gives us the green dot. Now, the basic block diagram shows the vertical and horizontal grids in a, we'll call a two-dimensional plane. This is more what it's really like. We're looking at the front of the tube, say, so you can see the horizontal plates or deflection grids are horizontal, left and right. The vertical's top and bottom. So when the beam gets deflected, as you see in the next diagram, you can see it can go right, left, up and down, or any angle for that matter. So in this diagram, I'm showing what happens when we apply horizontal drive. We're did away with the vertical because it works the same way, and we're more concerned with just a horizontal drive section. Anyways, you can see I've applied a horizontal sawtooth drive signal, and they're 180 degrees out of phase. So you'll see at one point, say on the top plate, or left and right, whichever you want to call it. But anyways, the one gets a negative charge because it's at the bottom end of the sawtooth. The other plate is on the positive side of the sawtooth, again, being 180 degrees out of phase. The electron beam being a negative charge, it sees a negative charge on the top, and it repels. The drive signal on the bottom is positive, so it attracts. So it bends the beam down towards the side of the phosphor on the front tube. And as the sawtooth signal goes back and forth, you'll get this beam being bent from side to side, side to side. Now, there is a bit more to it than this, but there is a blanking signal and all that, but that's not the concern here. This is just to give you the basics on how this works. So this is the situation I'm seeing when I had dual trace scope on the two deflection grids. The signals were in phase, as you can see in this block diagram. If I got positive on both grids, the potential is the same, so the beam's not going to be moved, so it just stays in the center. I get up and down for vertical, but nothing for horizontal. So how come they're in phase? It shouldn't be. So just to give you an idea what I'm going to be showing you next is this is the block diagram of the horizontal deflection amplifier board. It comes in on the left there, and you can either select external or internal inputs. We're going to be using internal, of course. It gets amplified and then split, and that's where the differential amplifiers come in play. One signal will be 0 degrees, the other will be 180 degrees out of phase. This is what I'm supposed to be seeing if the machine is working correctly, but I'm not. This is what I am seeing, and this is the puzzler. The bottom amplifiers of the differential amp is working okay, but look at the top one. The first 2 amps are out of phase like they're supposed to be, then the output's in phase. So why is it flipping like that? And it's exactly the same amplitude. It's not like there's a shorted transistor. You'd see a difference in amplitude, but they're identical. So there's the puzzler. Okay, so after looking at the deflection plates and noticing the 2 signals are in phase, I went back farther up the horizontal deflection circuit. What is it? There's a single horizontal deflection signal comes in, and it gets divided into differential amplifiers. So in other words, there should be two signals, but 180 degrees out of phase. So I'm at the earlier stage of the amplifier train here, and I go up and you can see it. Let me just zoom in a bit. And they're there. That's what they're supposed to look like. Now with this weird looking square sine wave thing, I can play with the kind of like horizontal deflection here, or positioning stuff, and it'll vary. But notice it stays, it's out of phase, 180 degrees out of phase. So why is it farther up in phase? That's why I'm thinking to myself, why am I having so much trouble with deflection here? So I kept going, and if I go up to the very last transistor, the last amplifiers, Q9 and Q12, go on the base of Q9 and Q12. That's these big ones here. Now it's going to be a lot stronger, I think. Emitter, base, I believe is that one. I think it goes here. And emitter base, I think, is this one here. And go to the scope. Still 180 degrees of phase. That looks good. This is the last. I'll show you. I'll show a schematic here. And so now I go to the collectors. Now the collectors output, that's what goes to the two wires here that go to the CRT, the deflection grids. Emitter base collector. Oh, things all twisted up here. Emitter base collector. Well, let's got some amplification now. So I'm gonna knock things down here a bunch. Oh, I'm going the wrong way. No, I'm going the right way here. Number 10. And they're in phase. Go figure. How could it be in phase? You know, it's a common emitter circuit. Should be shifting things 180 degrees out of phase. And it looks like these transistors are shorted, but they're not. They got gain. I measure for voltage. According to the schematic, everything's hunky-dory. So why is it in phase now? So I go back over. Actually, I'll leave it on the scope. And I disconnect one of the wires going to the... Actually, I'll disconnect them both. Wires going to the CRT. Now, actually, no, I should leave one hooked up. So, like I said, I've already done this, so I know what to expect. But okay, let's get some position here. No one's going to be stronger because it's disconnected. But there, look at this. They're out of phase. Just because I disconnected one of them. Now I'll hook this wire. I'll show you what I'm doing back over here. I got one wire disconnected. This is a wire that goes to the CRT up in here. And I connect it back on. I'll just show you back on the scope. I hook it back up again. They're in phase. They knocked it down because there's a load, but notice both of them are affected. And I said it was right there. Aha! I know what this is. So I'll show you here shortly in the next little show here. So again, I'm just showing here. The CRT is disconnected. You see the wires hanging off. I'm hooked up into the outputs of the amplifier. So these wires are the CRT. So nothing's connected at all. Go back over to the scope. Nice, beautiful looking signal. 180 degrees of phase. If I adjust the positioning, it does have an effect, but you know, a little bit. But the thing to note is 180 degrees out of phase. So I think I know what the problem is. Let's go back here. I'm going to disconnect all this, get it out of the way. I'm going to shut the machine off because I don't need it powered up for this. No, I'm going to just back off things here a little bit. Okay. So you can see this. Ohmmeter. I'm just doing an ohmmeter test. Circle these together. well, my leads are a bit funky, but essentially that. So hook on one wire going to the CRT, another wire going to CRT, 3.6 ohms. In other words, the two horizontal grids in here are shorted together. So if they're at the same potential, you get no deflection. So that hard bump destroyed the CRT. So, oh well, live and learn. So I put the lids back together and put the whole thing back together in one solid piece, and it's now joined my collection of antique equipment. So it's now back over here and sitting on the shelf with everything else. So I doubt very much I'll ever find a CRT, and it's probably not worth fixing anyway. So it was fun, but that's all there is. So, once again, thanks for watching. 73 from Skip, Victor Echo 6, Bravo, Golf Tango. Bye for now.